Well, disregard of its sign. Whenever you see these two lines, these are known as bars. Okay, whenever you see either a plus or negative value inside of these bars, we know that our absolute value would be the positive outcome of whatever's inside these bars. Okay, so what does that actually mean? Let's go to a number line. If I say I want to find what is the distance between -3 and 0, well, the distance would be known as 3 units. Okay, so since this is a measurement of distance, which would also always be positive, right? Think about it. If I had to ask you, hey, can you drive -2 kilometers? -2 kilometers, that would make absolutely no sense. So how can we drive a negative distance? Well, in this case, now we can see that deriving from this logic that our distance is going to be positive, whether it's on a number line, whether it's distance, whether it's time, etc. I mean, there's some cases you can use negative values, but that's very advanced physics. So again, the absolute value or the modulus, disregarding of its sign, would always be the positive outcome. Okay, it's just the distance between some value and 0. This is usually used in complex numbers where you have some sort of equation where this might be equal to x squared plus y squared, or etc. But this is for a later video if I make on complex numbers. Okay, so now that we know that we're always going to find the positive outcome, let's do some examples. What would be the distance between -8 and 0? Well, if this is 0, this is -8, what would be the distance between these 2 points? Well, it would just simply be 8. What about the distance from 7 all the way to 0? Simply 7. Now here's where the tricky part comes in. Now you get 2 absolute values. So the absolute value of 3 is 3, plus the absolute value of -4, we know now, is 4. So we get 4 plus 3, which is 7. Now following our order of operations, we're going to look at our absolute value using our definition where we disregard the negative values. And we can say, well, this is 4 minus the absolute value of 2, which is 2. And then I get my final answer, which will be 2. Okay, so how do we solve these type of equations? Well, first we're going to solve the inside of the absolute value before finding our final answer, which would always be positive. Okay, so we're going to have 4 plus -2. So think about it, 4 minus 2 minus 6. Okay, I'm just simplifying this. You can just solve this with one answer. So it's going to be 4 minus 2, which is 2, and then 2 minus 4, which is -4, but we need the absolute value. So the absolute value of -4 will be 4. So my final answer is going to be 4. Let's continue to some more complicated examples. Okay, so what's the absolute value of -12? Again, let's say we have the distance between -12 and 0. We know at this distance on a number line will be 12. So we can take the absolute value of -12, multiply our negative symbol, because this simply still means multiply. So my final answer would be -12. Now we add an algebraic component to this, meaning there's now some sort of variable. So what do we do in this case? Well, in this case, when we see a variable, we're going to set our absolute value to both positive and -8. Okay, so I can say 2x is equal to 8, and I can say, well, 2x minus 4 is equal to -8. Now I solve for x on both sides. How do I do this? Well, I always want to get my variables on the left hand side. So we can say plus 4 on both sides. These two cancel. That gives me 2x is equal to 12. I can divide with the coefficient of 2. That gives me x is equal to 6. Let's look at the second one. Second one, again, same thing. We're going to add 4 on both sides. These two cancel. We have 2x is equal to -4. and therefore x is equal to negative 2. So this would be my two final answers. So get one more. So now we have a multiplication in front of my absolute value. So how do we approach these type of questions? Well, we can approach it by, first, I'm going to subtract 7 on both sides. So we have 2 divided by 4x minus 2, or 2 multiplied 4x minus 2. And in this case, I have negative 2. Now, one thing to note in this case, we want to note that an absolute value can never be equal to a negative integer. So we can donate mathematical notation. So it's a z with a negative sign or negative exponent that shows negative integers. So in this case, we have a negative integer. So we cannot solve this equation since an absolute value cannot be equal to a negative value. Let's look at that in theory. So if I had to tell you, well, negative 4 is equal to, let's say the absolute value of negative 4 is negative 4. Why does this not make sense? Because the distance between some points, so let's say we have negative 4, negative 4. Let's say I add a distance of negative 4. Instead of moving towards 0, I'm going to move towards negative 8, right? If I say negative 0 and I need to travel another negative 4 distance, well, that would give me a total of negative 8. So instead of having my final destination at 0, my final destination will be negative 8. So therefore, through logical reasoning, we can say, well, an absolute value can never be equal to a negative value. So therefore, we cannot solve this equation. Something to take note of.